Okay, Jim Hannon here from Moonscapes. I want to put this video together after the last one I posted. I've been doing some astronomical work, and during that time I mentioned a trip to Vermont with my son, pan and gold, having a great time as usual. And this one turned out not so good. This is the one where Terry and I went out on a Saturday, and we did okay. Here's some of the gold we got on that particular day. And Terry was not feeling very well. He was coming down with a case of bronchitis. Pardon me. And Sunday, let's see, I think it was Sunday, and we were going to come home Monday. He got up, he was really, really sick, so he stayed back at the camper and stayed in bed. I stayed with him most of the day, and then decided to take a short trip out to the Waves River, not too far from where his camper was, and do some more prospecting just to see what I could come up with. And I got some more gold. I spent a couple hours and got a little more. This is probably the first day, Saturdays, and I added a little more to this on Sunday. And I was working a crevice on one side of the creek, and just going to pack up and go home and check on Terry. And looked across the way, and it looked like a very promising outcrop with some nice crevices in it just across the way. So I said, well, let's hold on, let's go over and check this out a little bit. So I did, went over, got a little more gold, not a lot, and was set to pick up the equipment and head back and check on Terry. And he was still back in bed. And as I'm picking up the equipment, I saw one more little spot that looked just a little too good, and I says, I got to do one more pan here. So, sure enough, I do another pan, and going to pick up my equipment and head back to check on Terry, and my snuffer bottle is gone. I had set it on a very safe place, at least I thought it was safe, on a flat rock nearby. Did the little digging into the trench and crevice that I found. Didn't see anything on the second dig out, so I'm picking up the equipment and looking around. Where's my snuffer bottle? Looking around, oh, I had to knock it down into a crevice in front. Nope, not there. Looked about 15-20 minutes all over the place. I had to have hit it with my elbow when I was digging in that last little crevice. Knocked it into the Williams River, and as I like to say, the Williams River ghost stole my gold that weekend. So I had one of those weekends where I had a great time. Unfortunately, Terry didn't have such a great day on that second trip when he got sick. But all the gold that I've got, which wasn't an awful lot, but it's enough to be happy to go home with from a trip to Vermont like that. And I went home with nothing because my snuffer bottle is somewhere in the Williams River and probably never to be found again. And just think of this for 1 minute. That gold you're looking at, when you get it out of that black sand, you are the first human being on the face of this earth to have ever seen that gold. That gold is created in supernova out in space, which we'll talk about here in a second. It makes its way to hydrogen clouds, gets picked up, forms new planets such as the Earth, and the gold gets swept up and forms with the planet. Kind of wants to sink to the center because it's so heavy, but it's brought to the surface by processes, geological processes that bring it to the surface, and of course it loves to attach itself to quartz, as we know. But it's just funny, you just think about it. You are the first human being to ever seen that gold that you're digging out of that black sand, and then you lose it down the river. Quite a disturbing day. So, with that, let's move on to what I was doing in astronomy. Let's see. This first image. Now, this is a black and white image. It was taken on the night of full moon. And one thing about working in astronomy, when you work on the night with a very bright moon, you really can't image in the RGB, or the red, green, and blue colors that get you the nice color image. But you can image in what's called hydrogen alpha light, which is a very, very deep red. This cloud of nebulosity you see is actually a cloud of hydrogen gas forming new stars. You can actually see the cluster right there in front, right in front of the nebulosity itself. This particular object is approximately Let's see, make sure I got that right. Yeah, just about 1,470 light years away. Relatively nearby object in our own universe. Now, this was the data that I acquired over a night of full moon. It's probably 90 minutes or an hour and an hour and a half's worth of data. And then 2 nights later, when the moon rose a little bit later, I did the RGB, the red, green, and blue work, and came up with this image. And this is with the color data added to it. And this is what you end up with. It's quite amazing the fact that I'm working from a very light polluted area near the center of the town I live in. But yet CCD astronomy is forgiving enough. We're using the proper filters and exposure times and being careful. You can pull some fairly nice data out of the background. This object lies in the Milky Way, down near the southern Milky Way in the star cloud near Scutum, and it's I would say all total with the black and white image and the color images here, we're probably looking at somewhere around 2.5 hours of exposure time. And to explain that in a simple and better way, a good way to think about it is catching light waves is the same thing as taking a bucket, and say you have a very light but steady rain going on outside. Now, if you put that bucket outside and leave it out there for, say, a minute, and bring it back in, and you got a damp bottom of your bucket. But if you leave that bucket outside all night long and let it go for 6 to 8 hours, the next morning you're going to go out there and you're going to have, a fair amount of water, an inch, inch and a half, 2 inches of water in the bucket. And it's the same thing. The CCD cameras are catching light waves, they're adding them up and stacking one on top of the other, coming up with this image. Again, this is the Eagle Nebula. The distance to this object is approximately 7,000 light years. Now, the last video I posted, this is the image I was working on. And unfortunately, I was having a lot of trouble holding the camera and working the controls, so what you saw was an image jumping all over the place. And of course you saw it coming in black and white, because as I say, each one of these images is taken in a different filter with a black and white camera. You have red, green, and blue light. All those exposures have to be taken individually. All told here, there's about 40 minutes of red, 40 minutes green, 40 minutes of blue added in there. And this image being not with that much red hydrogen gas in, I do not believe I added any hydrogen alpha gas into the light into this nebulosity. This object, which is called the Veil Nebula, lies about 1,470 light years away. And what you're actually seeing is the death of a star. There's a star that's probably somewhere out of the field over into here, which has gone supernova many thousands of years ago, long before there were modern humans around. And this is the gas cloud that's being blown off of that star. That's material. And actually what you're looking at is material to form new stars. And what they're called is second generation and even third generation stars. What I mean by that is our sun is actually a second generation star. It has mostly a hydrogen gas converting over to helium, but it also has some heavier elements in it. And the only place those heavier elements could have come from was from within the action of older stars which have exploded and formed heavier elements, because the sun burns by converting hydrogen to helium, and without getting technical, and of course I don't know the math behind it, so I can explain it simply. The sun burns by converting hydrogen to helium in its core through nuclear reactions, and it creates heavier and heavier elements, oxygen, carbon, and all the way down to iron. When it gets to iron, it can no longer process it, and the star will shrink. And in our case, it'll just shrink and become a lot hotter as it shrinks to a much smaller state, and then spend the rest of its life as a white dwarf after puffing off a cloud of gas like this. Stars that are more than 1.47 times the size and mass of our sun, and even up to 8 and 9 and 10 and even larger than that, will form very bizarre objects, anywhere from a neutron star which is a very, very, very heavy star with a star that would shrink down because of its heavy gravity, probably to the size of New York City, and a teaspoon would weigh tons. You wouldn't even be able to pick it up. That's how dense it would be. Or the star would go supernova, completely blowing itself to bits. And good old Einstein, let's try that again, came up with his theory of relativity, and if the star is massive enough, it would form a black hole. Even he thought that this was just impossible. He thought it was too bizarre, and even though his math proved they should be there, he just would not accept it. But yes, we do know today that there are such a thing as black holes. So there's a story of the astronomy that I've worked on over the last couple of probably the weeks, and my trip of lost gold. And of all of them, the lost gold trip bothers me the most because, as my son likes to say, a little something for the effort, and I got nothing for the effort on that weekend other than being up in the nice air woods of Vermont. So that's it, guys. Gonna have a little knee surgery coming up on Friday. Nothing serious, orthoscopic. I should be up and around not too long, and hopefully be getting up north again with Terry very, very quickly and doing some more astronomical work. So hope to talk to you guys soon, and hope you enjoyed this. Take care now.